Okay, let's do this example here. So this is another inequality with polynomials. So now what we're going to do is we're going to do the same thing. I'm just going to move everything to the left. So that means I'm going to subtract off 8x squared from both sides. And I'm going to add x cubed to both sides. Okay, so when I do that, these are going to go away, and so I'm going to get, so I'm going to add like terms here. There are no like terms to add, if you notice. So I'm going to write this in decreasing order, so we get x to the fourth plus x cubed minus 8x squared minus 12x is greater than or equal to 0. Okay, so the first thing when you do is I'm going to set this equal to 0, right? And now I'm going to factor this and find all the real zeros. So the first thing I'm going to do is I'm going to factor out an x. Okay. And now what I'm going to do is I'm also going to see if I can factor this. And let's see, it looks like can we factor by grouping here? So if I group these two, let's see. That's not going to give me a that's not going to give me a common factor. Okay, let's see here. A factor on x squared is going to give me x plus 1. I'm not going to get an x plus 1 over there. Okay, so at this point I can use rational, all possible rational zeros. So remember the A0, AN. So it's going to be all the factors of negative 12, right? That's going to give me plus or minus 1, plus or minus 2, 3, 4, 6, and 12. And so we could try plus or minus 1. So again, let's add the coefficients. So we got 1 plus 1 is 2 minus 12. So that's not going to do it. If we do negative 1, that's going to give us negative 1 plus 1, which is 0. This is going to give us 8 minus 12, which is still not going to give us 0. So now let's go to 2, right? So if we do 2, that's going to give us 8 plus 4, right? 8 plus 4 is 12, which gives us 0 with this, but then it's not going to give us 0 with that. If we do negative 2, that's going to give us negative 8 plus 4, which is going to give us negative 4 which is going to give us negative 16. We put in negative 2, that's going to give us positive 16. So negative 2 will work. So let's find out what the quotient's going to be. That means, if negative 2 works, that means x plus 2 is a factor. Right? Because remember, x minus c, right? So it's x minus negative 2, which is x plus 2. All right. So now let's do our synthetic division, see what the quotient is going to be. So it's going to be negative 2. And what are our coefficients? It's going to be 1, 1, negative 8, negative 12, right? So let's go through this thing. So that's 1, so negative 1, that's going to give us negative 2. So that's going to give us negative 1. That's going to give us positive 2. And so that's going to give us what? It's going to give us negative 6, which then is going to give us positive 12, which is going to give us 0, which is what we knew, but we want the quotient. So now it's going to factor into x times x plus 2 times, now it's going to be a quadratic, so it's going to be x squared minus x minus 6 is equal to 0. Now let's see what we can do to factor this, right? Instead of doing more of this, let's just see if we can factor it, okay? So this is negative 6, so 2 factors in negative 6, that will give us negative 1. 2 times negative 3 will do it. So now we got it. So 2 is a repeated factor. So actually we got another 2 out of that, right? 2 and negative 3. So that means, oh, it's negative here, so negative here. Yeah, 2 and negative 3. Yeah, so it's going to be x times x plus 2 squared times x minus 3 is equal to 0. All right, now we have our interval. So let's go back. I'm going to go back to this. We don't need this anymore, right? So now we've got the factors. That's as soon as we got it in factored form, we're done. We're pretty much done. It's all downhill. So now what we're going to do is we're going to set up our intervals. Our intervals. Well, first of all, our zeros. We didn't do our zeros. So let's do the zeros. So we're going to have a 0 at 0, right? So our zeros, or our solution, right? Our real solutions to this is going to be at x equals 0, x equals negative 2, and x equals 3. So now, this is what we're going to use to set up our intervals, right? So our first interval is going to go from negative infinity to negative 2. And then our second interval will go from negative 2 to 0. And our third interval will go from 0 to 3. Oh, I didn't give myself enough room. Let's do this again. So our next interval is going to be from -2 to 0, and then from 0 to 3, and then from 3 to positive infinity. So in this case here we have 4 intervals to test. Okay, so let's look at our equation here in factored form. So now we're going to do a test point, and we're going to test the sign of the function in each one. So when, let's pick -3. If x is -3, we got negative. Here, this is negative, but it's squared, so this whole thing's going to be positive. And in fact, regardless of what x is, this is always going to be positive. And then x here, if I get -3, it's going to be negative. So I get negative times a negative, which is positive, times a positive, which is positive. So it's going to be positive here. Now let's choose here, -1. Let's do -1. So this will still be negative, this will be negative, this will be positive, this is going to be negative. So this whole thing is going to be positive. Now what about 0 to 3? Let's choose 1. Well, +1, it's going to be positive, this is going to be positive, and this is going to be negative. So now the whole thing, if we take the product of all these, positive times a positive times a negative is negative. And now going here, let's choose 4. So 4, that's going to be positive, this is going to be positive, this is going to be positive, which means the whole thing is going to be positive. So the sign of the function is positive. Okay, so I'm going to put sign. So we got the signs. Now, we test the endpoints, right? So, that's where the inequality comes back, right? So what's the inequality in this case? The inequality was greater than or equal to. Since we have equals, that means we're going to include the endpoints in the solution set. So greater than means positive. So this is positive, this is positive, this is positive. This one's negative. So this is going to be gone. So that means what we're going to do is we're going to include the endpoints for this one because we're including the equals, right? So if it's equal to 0, it's okay. Okay, so now these intervals are both positive all the way around, except at 2 where it's 0, but that's okay because we're accepting equals. So that means the solution to this inequality is going to be from -infinity all the way to 0, because 0 is included, right? So we're going to go here. So that's the way we're going to do the first one, because it's positive or 0 all the way from -infinity to 0. Then we're going to take the union of the next interval where it's greater than or equal to 0, and that's going to be from 3 to positive infinity. Okay. And so set builder notation, so this is interval notation. Set builder notation again would be the set of all x such that x is an element of what? Negative infinity to 0, union 3 to positive infinity. Right? So we could write it as an element of that, or we could write it that x is less than or equal to 0 or greater than negative infinity, or, right? So x is in this interval, or x is less than positive infinity and greater than or equal to 3. And that's it. Have a great day.